Welcome back to Databytez, your source for data-driven principles. We are back on the technical side of data with the levels of measurement. Why 1 does not equal 1. So diving straight into it, why are the levels of measurement important? Well, for starters, they are a mean of categorizing data based on their properties. We have a way of systematically evaluating data and making sense of it. 2, determining a dimension, features, variables, level of measurement tells you what sort of analysis you can conduct. Just because it's a number doesn't mean you can do all the maths on it. There are certain restrictions based on context. And side note, why I include dimension, feature, variable, it really is because in data, at least as my opinion is concerned, it's a lot of renaming of the same thing, and that can lead to a bit of confusion. I think so, because it's all the same. So if you're looking more of at a statistician's perspective, you would probably be saying variable. What are the variables features? Variables characteristics. If you're looking at it from an analyst point of view, you might be saying the dimensions of your data set. And if you're looking at a machine learning, you'll be saying features. That's what your kind of terminology you'll be using. And then ultimately, using the levels of measurement, you can just better understand your data set, which is always a good thing. You always want to know more about your data set. It's kind of important. Now, what are the levels of measurement? Well, there are 4, and they all kind of build on one another. So we have nominal, which is just categorical in nature. There's not much you can do with it. You have ordinal, which is categorical, but has direction, has order, so you can rank it. Interval is data that can be categorized, ranked, and is evenly spaced. And ratio, data that can be categorized, ranked, evenly spaced, and has a natural zero. This natural zero is very important as an idea. And as we go through this, it'll make more sense what that natural zero means. But that's really the distinguishing characteristic between interval and ratio. So starting with nominal, mathematical operations include equality. All you can really do is just say, hey, are 2 classes equal? That's about it. Measures of central tendency include mode. You can just determine what's the class that shows up most often. Measures of dispersion, none. There's nothing you can do. So what are examples? Well, there's city, ethnicity, marital status. So you can determine if 2 people live in the same city. If you had a data set, you can see which city is the one that comes up most often, but that's really about it. There's nothing else you can really do. Same with ethnicity and marital status. As if you had a data set, you can determine what is the most, if 2 ethnicities are equal, if two rows have the same ethnicity, or which one is the one that comes most often, but that's about it. Moving on to ordinal. So now we introduce a new mathematical operation in comparison. You're able to say, is this one better than the other, right? Because there is an order to it. You're now able to say, what is the median that appears in ordinal data? And you're actually able to start using measures of dispersion. What is the range? What is the interquartile range? Now, what are examples of ordinal data? Well, you have proficiency level, beginner, intermediate, advanced. Of course, as you ascend from a beginner to an advanced practitioner, there is a certain directionality there. And the Likert style questions are ones that you answered, I'm sure, at least one survey in your life. It's the very dissatisfied to very satisfied. And sometimes they'll put a number on there, which leads me to my next point. How do you even compare things? How do you compare something like beginner and advanced, very dissatisfied to very satisfied, with it mathematically when they are words? And that's through encoding, right? We can encode these values to be associated with a particular number. So you can, and normally on these Likert questions, very dissatisfied is given either a 0, right? And very satisfied is a 10. You can say beginner is a 1 and advanced is a 3. And so with assigning that, encoding that into a number, you're then free to do more mathematical operations like comparison and median and then range, right? You're able to take the difference between a 10 and a 0. What is the range from the highest reported answer on our questionnaire to the lowest? It's a 10. And you're able to then do the interquartile range as well. So going on to level 3, we have interval data. So now we have the ability to add and subtract, and we add the mean as a measure of central tendency, and now we're able to take the variance and standard deviation. So now we're kind of really doing basically everything in terms of mathematics and our standard tool set for conducting analysis. So examples here include temperature, like Celsius and or Fahrenheit, and credit scores. Now, something important here, and we're going to also revisit this as we go on to ratios, is that there is no natural zero. So having a 0 credit score, which I don't think exists, if you have a 0 credit score, let me know in the comments, because I feel for you potentially, and I don't think you can really achieve that, but maybe I'm wrong. And then there's temperature, just in Celsius, Fahrenheit in particular, because 0 degrees Celsius does not actually mean 0 degrees, because I believe 0 degrees Celsius means like 32 or negative 32 degrees Fahrenheit. So there's no actual 0 there. There's no real 0. And just because you have a 0 credit score doesn't mean you're devoid of credit worthiness. So that 0 doesn't actually mean anything. It doesn't mean true absence. But when we just go on to our next one, our ratio, where we introduce multiplication and division, and we're able to add the geometric mean and the relative standard deviation for measures of central tendency and measures of dispersion respectively. Now, I've never really had to take the geometric mean or relative standard deviation in anything, but the options are open to you if you want to do something like that. And so what are examples of ratio data? And that we have age, we have temperatures in Kelvin, and physical inventory. So, if you're 0 years old, you have no age. That's a thing that has a natural 0. Kelvin at 0 degrees means true absence. So in this case, not even atoms and their subatomic particles move. It is the true absence of any kind of kinetic energy, any kind of warmth. So 0 degrees Kelvin means something. And physical inventory, of course, if you have 0 of something, you have 0 of something. There's a natural thing. Not having any things means something there. And so going back to part of where we started here, why 1 does not equal 1, at least all the time. And so we have a little table here that I made together, I stitched up. We have two different classes, but 3 rows. And we have 1 and 2. And we have inventory. So we have 1 of class 1, 4 inventory of class 2, and 0 again of class 1. It should be a class 3. Let's not get into details here dissecting it. But we have 3 different things going on. I didn't really put a lot of thought when I put this together. And so the point here is that we can't really compare the two. So if I want to say 1 is equal to 1, I can't really do that across the 2 different columns because they're operating on 2 different levels of measurement. If I were to take away that header, if you were to put your hand to the screen and pretend class and inventory didn't exist, you might think you can compare them. You might think these are just 2 numbers, but it's not really the case. They're 2 separate things. They operate in 2 different worlds, really. You can't assume you can add 1 plus 1 to get 2. You can't do 2 plus 4. It's 2 different animals. And so that is why 1 does not equal 1. Now there is a how. There is a how to kind of translate this into the actual technology you're using, but this is more the theory, the idea, the framework that you're going to be using to kind of make sense of the data that comes across your way. Anyways, I hope this has been useful. If I know I talk a little fast, so feel free to rerun this for a part you didn't get. And if you wanted me to cover in anything in particular, please let me know in the comments below. As always, this is Patrick trying to give you data-driven content. Stay data-driven yourself, and until next time, have a good one. Bye.